Welcome to The Explainer. Today, we're diving into the world of statistics, and we're going to do it by chasing down the answer to one really interesting question.
So, here it is. Do married men really live longer? I mean, it's a thing you've probably heard before, right? It seems so simple on the surface, but how could you possibly know for sure? How do you even start to tackle a question that big?
Well, it turns out a pretty famous study found a surprising link, and today we're going to follow in their footsteps. We're going to see exactly how they did it, and we'll be using the powerful tools of statistics to guide us.
All right, first up, answering a big question. Before we can get to the answer, we got to understand the tools they used.
Okay, so the textbook will tell you that statistics is the science of collecting, organizing, analyzing, and interpreting data, which is, true. But what is it really? I like to think of it as a toolkit for turning curiosity into actual knowledge. It's the bridge that takes us from, I wonder, all the way to, okay, now I know.
So right away, the researchers hit a massive wall. If you want to know if married men live longer, well, you can't exactly study every single man on the entire planet, can you? And this brings us to one of the most fundamental ideas in all of statistics.
Okay, so think of it like this. On one side, you've got the population. That's the entire group you're interested in, the whole shebang. In this case, it's all men everywhere. It's just impossibly huge. But then on the other side, you have your sample. That's a smaller, more manageable slice of that population. Like the few thousand men they could actually include in the study. The whole goal here is to learn something true about that giant group by just looking at the small one.
And this gets us to the absolute heart of the challenge. A parameter is a number that describes the entire population. That's the true, real answer we're desperate to know. But a statistic, well, that's a number that describes our sample. That's the thing we can actually go out and measure. So the whole game really is using that statistic we can measure to make a super educated guess about the parameter we can't.
So this leads to the million-dollar question. How in the world do you pick a good sample? Because think about it. If your sample doesn't actually look like the bigger population, then any conclusions you make are going to be totally worthless.
To get it right, researchers have this whole toolkit of methods. The gold standard? That's a random sample, where absolutely everyone has an equal shot of being picked. Simple and fair. But what if you need to make sure you have enough men from different age groups? Well, that's when you'd use a stratified sample. Or what if your population is spread all over the country? Cluster sampling might be way more practical. See? Each method is designed to solve a different kind of problem. Okay, so once our researchers have their sample, how do they actually get the information, the clues? Well, for a study on longevity, they most likely used surveys to ask about things like marital status, and then they'd have to do long-term observations, tracking these guys' health for decades.
And the data they collect, it basically falls into two big buckets. You've got qualitative data, which is all about describing categories. For our study, that's simple, married or unmarried. Then you've got quantitative data, which deals with the numbers, like a person's age or weight. You really need both to paint the full picture.
All right, quick pop quiz for you. Think about your favorite song right now. Is the title of that song qualitative or quantitative data? It's qualitative, right? Because a song title is a name, a category. It's not a number you can measure or do math with.
But here's the thing. Not all data is created equal. You can think of it like climbing a ladder of information. At the very bottom, you have nominal data, like marital status. It just puts things in boxes, no order. A step up, you get ordinal data, which adds an order, like movie ratings. Good, better, best. Then you get to interval data, where the differences between numbers actually mean something, like temperature. And right at the top, you've got ratio data, which has a true zero. Think about a person's age. The higher you climb this ladder, the more powerful your analysis can be.
Okay, so the researchers have picked their sample, they've collected all this data. Their first job is actually pretty simple. It's just to describe what they see.
This is a whole branch called descriptive statistics, and it's not about making these huge, grand conclusions just yet. Nope, it's simply about organizing and summarizing the facts of your sample in a clear, honest way. Think of it as the just the facts part of the process.
And in that longevity study, the researchers found a very, very powerful descriptive statistic. For the married men in their sample, this was a survival rate at age 65.
Yeah, that's right. A staggering 90%. But here's the comparison that makes it so powerful. For the unmarried men in the study, it was only about 70%. That 20-point difference, that's a stark, factual descriptive statistic. It tells us exactly what they saw in their little group. But, and this is a big but, that's not the end of the story.
Because now
Now we get to the most exciting part of statistics. We have this one fact about our small sample. Now we have to make the big leap.
So, does this dramatic 20-point difference they found in a few thousand guys, does that actually apply to all men everywhere? Can we really generalize from this one specific finding?
This is the job of inferential statistics. This is where the magic happens. It's the branch that lets us use that sample data to draw conclusions, to make an inference, a really good educated guess about the entire population.
So let's just put it all together one last time. Descriptive statistics tells you what the data says about your sample. Hey, 90% of men in our sample were alive. But inferential statistics, that helps you decide what the data means for everyone else. So we predict that married men in general are more likely to live longer. See the difference? It's the leap from a single fact to a broad conclusion.
And this is why all of this matters so much. Look, we can't ever survey every single person or test every single product. It's just not possible. Statistics gives us a rigorous scientific way to take small, limited bits of data and turn them into these powerful, sweeping insights about the world around us.
It lets us find the signal in all the noise. And that leaves us with one final thought. What other hidden stories, what other surprising connections are just waiting to be told in all the data that's swirling around us every single day?